Hi everyone, we're continuing our adventure of finding trig values all around the world. In this example, we'll evaluate, or simplify, basically, cosecant of 7 pi. Well, 7 pi is too big, so it will help to find a nicer coterminal angle. Let's find a nicer coterminal angle. Well, to find coterminal angles, we can add or subtract 2 pi. We start with 7 pi. If we subtract 2 pi, we get 5 pi. If we subtract 2 pi again, we get 3 pi. If we subtract 2 pi again, we get 1 pi. And 1 pi is finally a pretty nice angle. So let's go ahead and say that 7 pi is coterminal with pi. We know pi pretty well. Now, if this seemed too tedious for you, well, remember that when we go from 7 pi to pi, we're basically subtracting 6 pi. And that is legal. You can get a coterminal angle by subtracting 2 pi, 4 pi, 6 pi, or so forth, or add those angles. However, do not add or subtract 1 pi, 3 pi, or 5 pi, otherwise you'll be on the other side of the origin, and you don't want to do that. So to find a coterminal angle, you can add or subtract 2 pi, 4 pi, 6 pi, 8 pi, and so forth. Here, you can subtract 6 pi. All right, 7 pi is coterminal with pi, which means that cosecant of 7 pi will be equal to cosecant of pi, or maybe they're both undefined, in which case equals would technically not be appropriate. All right, so what's the deal? Cosecant of pi, well, I know sine better, right? Cosecant of pi is the reciprocal of sine of pi. Cosine of pi is the reciprocal of sine of pi. What is the sine of pi? I'll put this in blue. What is the sine of pi? The sine of pi is the y-coordinate of this point over here on the unit circle. What's the y-coordinate of this point corresponding to pi radians? The y-coordinate is, it's 0. So we're talking 1 over 0. 1 over 0 is undefined. Cosecant of pi is undefined, therefore this thing is undefined. Cosecant of 7 pi is undefined. That happens sometimes. For quadrantal angles, that can happen. By the way, cosecant of pi was also undefined. Okay. Now let's say you're dealing with degrees. Remember that finding reference angles for special angles is very easy if you're dealing with radians. For degrees, it's actually a bit trickier. So let's say that you have an angle, theta, that you care about. First, you might want to find a coterminal angle, alpha, because your angle theta might be too big or too small or negative. So find a coterminal angle, alpha, that's either between 0 degrees and 360 degrees, or it could be slightly negative. So here's how you would find a reference angle for either theta or alpha, this nice coterminal angle. Bottom line, you're going to take the absolute value of some flat angle minus alpha, this nice coterminal angle you're dealing with. It could be the original angle. Now, what do I mean by a famous flat angle? Okay, so the flat angles basically correspond to the x-axis. 0 degrees, over here, 180 degrees, back over here, 360 degrees. Okay, these are the relevant flat angles. Okay, but in the vicinity of 0 degrees to 360 degrees. Determine which famous flat angle associated with the x-axis is closest to your angle alpha among these. Okay, and the reference angle is going to be the absolute value of the difference between the two. So absolute value of flat angle minus alpha. We'll apply this in just a moment. So for example, let's evaluate the tangent of negative 225 degrees. Right off the bat, you might want to convert negative 225 degrees to radians and use the procedures we've used before. That might be easier. But let's say that you want to stick with degrees. Well, there's a problem. Negative 225 degrees is a pretty bad negative angle. I'm sure we'll want a coterminal angle. And how can we find a coterminal angle for negative 225 degrees? We add how much? We add 360 degrees. When we do that, we observe that negative 225 degrees plus 360 degrees is 135 degrees. That's our value for alpha, the nice coterminal angle. And then, what's the reference angle for both these guys, the 135 degrees and the negative 225 degrees? All right. Well, incidentally, you might care about the quadrant first. What quadrant is 135 degrees in? 135 degrees is going to be in quadrant 2. Quadrant 2. This is 135 degrees. All right, quadrant 2. We're in quadrant 2. All right. Now, what's going to be the reference angle? What's going to be the reference angle over here? The reference angle over here. We use this formula. The absolute value of the relevant flat angle minus our alpha, 135 degrees. What's the closest flat angle to 135 degrees? It's going to be 180 degrees. That's the closest one of these three to 135 degrees. So we take the absolute value of 180 degrees minus 135 degrees. That's 45 degrees. That's going to be the reference angle. So at this point, I know the key information for both this angle and this angle. I know that the reference angle, I'll type this out. I know that the reference angle is going to be 45 degrees, and I know that we're in quadrant 2. That's true for both the 225 degree angle and the 135 degree angle. Now we're down to 45 degrees. Bottom line. This thing here is either going to be plus or minus the tangent of 45 degrees. We're getting down to that reference angle in quadrant 1, a famous acute angle. What is the tangent of 45 degrees? What's the tangent of 45 degrees? It's 1. Famously, it's 1. So our answer is going to be either plus or minus 1. Plus or minus 1. But which one is it? Well, we're in quadrant 2, remember? We're in quadrant 2. And in quadrant 2, slope is negative. Slope is negative. Also, all students take calculus. In quadrant 2, sine and cosecant are positive. The other guys, like tangent, they're negative. So the tangent of negative 225 degrees is going to be the same as the tangent of 135 degrees because these two angles are coterminal. The answer for both will be negative 1. 1 is the tangent of 45 degrees, the reference angle, but we have to sign it negative because these two angles over here are in quadrant 2. That's a lot of stuff there. It might be easier to just go to radians. In the next video, we're going to talk about some more identities. We've dealt with 3 groups. We're going to deal with groups 4 and 5 next time.